All right, guys, we're on the back side of day 2 notes, and up at the top it says if a line is tangent to a circle, the line is perpendicular to the radius drawn to the point of tangency. Okay, so all that means is that when we have a tangent line here, and it's tangent because it just touches the circle once, okay, and this is a radius, then that radius is perpendicular to that tangent. And then we now know that these are 90-degree angles. Okay, another way you can think of it is this radius actually being a diameter going all the way across, and this being the angle we were talking about on the front with the tangent and the chord, and that this is 180 degrees for that. And so that acts like an inscribed angle, and it would be half the arc, or half of 180 is 90. Okay. And they want you to find the measure of angle AKO, and we just did. It's 90 degrees. Okay. So just remember that a radius or a diameter, okay, and a tangent, they're perpendicular. Okay. All right, another one we could talk about. Two inscribed angles intercept the same arc. The angles are congruent. Inscribed angles that intercept the same arc. The angles are congruent. Okay. And also arcs between parallel lines are also congruent. Okay. So we got two things there to talk about. So in number 7, it says that given AB is parallel to CD, and the measure of angle ABC, A to B to C, this angle here is 40 degrees. They want us to find the following. So we'll go ahead and find measure of arc AC. And that's a little easy because 40 degrees is the inscribed angle. So the arc would have to be 80 so that the inscribed angle is equal to half the arc. Okay, so this has to be 80. Part B says the measure of angle ADC. Measure of angle A to D to C. Well, that's an inscribed angle that also has that same arc, and so this has to be 40 degrees so that the inscribed angle is half the arc. Okay, and so this is 40. Okay. If I continue on, part C is asking us to find the measure of angle BCD. So from B to C to D. All right, and so I believe this is what they were talking about with arcs between parallel lines. Okay. Because these lines are parallel, this arc on the left-hand side has to be the same measurement as the arc on the right-hand side, and so this has to be 80 degrees, and that's actually part D. Find the measure of arc BD. Okay, and so we could put 80 degrees there. Okay. Also, the other way we could have gotten this angle is that parallel lines cut by a transversal. Do you see the Z shape? I'll trace it again. Okay. So because we're trying to figure out this angle down here, we could have said, oh, that's 40 degrees as its alternate interior angle, so this has to be 40 degrees down here. Okay. And then our last one, the measure of angle BAD. So B to A to D. Well, we could either go with alternate interior angles and copy the 40 up here, or we could look at the arc and say that half the arc equals that inscribed angle, so this has to be 40 degrees. Okay, so lots of ways of looking at it. And now that we know all that, let's take a look at some of these examples. In number 8, it says find the value of A and then find the measure of arc ZY. So if we take a look at these two expressions that they gave us, they're indicating that they are inscribed angles. Okay? And the one angle has the same exact arc as the other. Okay? And so whatever this number is out here, you would take half of it and you would get this one and that. And so we have to realize that those two angles would be equal to each other. They would have exactly the same measurement because you're taking half of the same number. All right. So if we go ahead and we solve our equation, we have A minus 9 equals 1. If we add 9 to it, we get A equals 10. And that's one of the two things they ask us to find. Okay? They also asked us to find the measure of ZY, arc ZY. So what we're going to do is we're going to plug into either one of our angles. So we're going to go 8 times 10 minus 9 is 80 minus 9, which is 71 degrees. This angle should also be 71 degrees, and we could check too. 7 times 10 plus 1 is 71, okay? And so that this arc out here had to be 142. So that half the arc would equal the inscribed angle, okay? All right, number 9. It says find the value of x in circle O. All right, and so this is a nice question because it brings in our central angle that we had on day 1. And so remember, central angles are equal to their arc, and so the arc would be 80. But angle x that we have to find is an inscribed angle, and inscribed angles are equal to half their arc. And so half of 80 makes x come out to equal 40 degrees. Okay. Number 10, find the value of x in circle O. Okay. And so we can do this one a couple ways. One way I like to do it is that 40 degrees on the other side here would be 140 because they're a linear pair. Okay? And these two sides are both radii of the circle, and so the angles across from those equal sides are equal. And so 180 degrees minus that vertex angle of 140 leaves me 40 left over, but I have to split it equally. Okay? And I end up with 20 degrees here and 20 degrees here. Okay? And so x equals 20 degrees. Another way that you can look at it is that if you follow this angle out, because it's a central angle, that this arc would be 40 degrees. Okay? And then this is an inscribed angle, so it would be half the arc, and that could be how you got your 20. Okay? This arc has to be 140 degrees, and that's one way you could get your 140 here too. Okay? And then you could do triangle sum to figure out that that's 20 degrees. Okay? So a couple ways you could do it. Number 11. In the accompanied diagram, isosceles triangle ABC is inscribed in the circle. And if AB is congruent to CB, and the measure of arc AB is 150, find the measure of angle B. Okay? So we can go ahead and say, well, this inscribed angle right here would have the 150 as its arc, and so half of the arc would be 75. Okay. Angles across from congruent sides are congruent, so this angle would be 75. And now I can take my triangle sum and take away the 275s, and be left with 30 degrees left for the vertex angle. Okay. Another thing you could have done is that you could have said that this arc over here is 150 degrees. Okay. And that this arc down here had to be 60 degrees to make the full circle for 360, and that half of 60 is 30. Okay. So either way. All right, number 12. We have triangle ABC is inscribed in a circle. So always draw your circle first, and then pick 3 points on your circle to be the 3 vertices of your triangle. And there's your inscribed triangle. Okay, it's called ABC. And it says that the ratio of the measures of AB to BC to CA are 1 to 5 to 9. And so what that means is that AB is first, 1 is first, AB gets a 1x. BC is second, 5 is second, so BC gets a 5x. And CA is third, and 9 is third, and so CA gets a 9x. And since those are the 3 arcs of our circle, we're going to add them all together up, which is 15x, and that equals 360 degrees. Okay, if I divide by 15, x is going to come out to be 24. And now I can go ahead and say that this arc is 24 degrees. That 5 times 24 would be 120 degrees. And that 9 times 24 is 216 degrees. Okay. And now that I found all my arcs, that was part A, B, and C. So I'm just going to copy them over. Arc AB is 24 degrees. BC is 120 degrees. And arc AC is 216 degrees. Okay? And now I'm going to go ahead and find all these angles. Because they're all inscribed angles, all I have to do is follow them out to the arc and take half of it, because inscribed angles are equal to half their arc. Okay? Angle B, if I follow that angle out, it's 216, and half of 216 is 108. And angle C, follow it out, 24, so half the arc would be 12 degrees. And if I add those three up, it should equal to 180 degrees for the sum of the triangle. Okay. All right, guys, hopefully that was good on inscribed angles. I'll see you guys next time.